Okay, here we go. My geometry students, we have our quiz on Thursday over 5 sections. A lot of material, so here's 10 examples to go off of. Okay, number 1 here. Find the value of each variable. Okay, so this is coming from the section on interior and exterior angles. So if I look here, okay, first I need to find y and z. Z is an interior angle next to 110, which is an exterior angle. The relationship between an interior and exterior angle is the fact that they are supplementary. Z plus 110 equals 180. Subtract 110. Z is 70. And I'm going to mark that in my picture that Z is 70. And now, to find y, I'm going to use the sum of these interior angles. Now remember that the sum of the interior angles is equal to n minus 2 times 180. Right? This is a quadrilateral, 4 sides. 4 minus 2 times 180, that's 2 times 180, that's 360. So these 4 angles add up to 360. Y plus 70 plus 87 plus 100 is 360. Add these 3 angles up. That's 157 and 100 is 257. And subtract 257. And we get y is 103. There you go. Interior, exterior angle problem. 2. The measure of an exterior angle of a regular polygon is given. And this word regular is very important. Find the measure of an interior angle, then find the number of sides. So remember, if this is my exterior angle, the interior angle and exterior angle are supplementary. The interior angle plus 36 equals 180. Subtract 36. So the interior angle measures 144 degrees. And then if I want to find the number of sides, there's 2 ways. I'm going to use the exterior angle. Okay, remember that the measure of an exterior angle, so each exterior angle of a regular polygon is equal to 360 divided by the number of sides, because 360 is the sum of them all, and I divide by n because there would be n exterior angles for n sides. So I'm given that the measure of one of them is 36, and I want to find out what n is. Multiply by n. 36n is 360. Divide by 36. N is 10. This thing has 10 sides. It is called a decagon. Okay, if you were wondering. Okay, so there's another interior exterior angle problem. Alright, 3. Moving on. Find the values of x and y in this parallelogram. And what do I have? Well, PT is x plus 2. That's this part of the diagonal. TR is y. QT is 2x. And TS is y plus 3. The idea here is that the diagonals of a parallelogram bisect each other. So I know in blue that PT and TR are congruent, and I know that QT and TS are congruent. So let's set up these 2 equations. So PT, x plus 2, is equal to TR, y. Uh-oh, 2 different variables. That stinks. Let's try the other ones. QT, 2x is equal to TS, y plus 3. Uh-oh, 2 different variables. Bummer. We have to solve this as a system of equations. Now, what is nice? Top equation is already solved for y. Plug x plus 2 in for y into the other equation. 2x equals x plus 2 plus 3. So that is this equation with y replaced with x plus 2. Now these parentheses don't really mean nothing. So let's just add 3 and 2. And let's subtract x. X is 5. So now, to find y, plug it back into that top equation. 5 plus 2 is y, and y is 7. And if you plug it in, right, each of those should be congruent to its partner. So PT would be 7, and TR is 7. QT would be 10, and TS would be 10. So it works out well. System of equations, make sure you practice. 4. Proof time. Here we go. 2-column proof. Statements. reasons. You're given two parallelograms. Parallelogram LENS and parallelogram NGTH. You need to prove that angle L is congruent to angle T. Okay? So if I mark them congruent right now, the question is, how do I get from L to T? And the answer is right here. I'm going to use those vertical angles. Vertical angles are congruent. And I can use these two angles to then propult me, or catapult me, from L to T. Propult me. I don't know what that means. So this reason is given. So let's start with angle L. Angle L, let's start with angle L. Angle L is congruent to angle, and call this ENS. And that is, of course, because opposite angles in a parallelogram are congruent. So then, let's go with angle ENS. Angle ENS is congruent to, and we'll call it angle GNH. And that's because they're vertical angles. See how these two parallelograms touch? Vertical angles theorem says vertical angles are congruent. And then, finally, angle GNH is congruent to angle T. And that is because, again, opposite angles in a parallelogram are congruent. And now look what we have. L congruent to ENS, ENS congruent to GNH, GNH congruent to angle T. We have a double transitive property situation. That'll then let us connect angle L to angle T. Transitive property. Okay? So again, remember, a lot of it has to do with the angle measures and using transitive property. Okay, 4 down, 6 to go. Here we go. Number 5. Can you prove that the quadrilateral is a parallelogram based on the information? Explain. Well, let's see what you know. You know that both pairs of opposite sides are congruent. That's one of the properties of a parallelogram. So yes, because both pairs, not sides, angles, both pairs of opposite angles are congruent. And there you go. So remember, it's just, is there a statement or a property or definition that it works for? If it is, then just write it down. So it should be yes or no, right? Black or white, yes or no, why? Okay. 6. For what values of the variable must A, B, C, D be a parallelogram? Okay, so in this one, we're going to use the fact that opposite sides of a parallelogram are congruent. Now if you look here, you have 4 sides or 3 sides with y and 1 side with x. I would stay away from the side with x, right? So let's take the top and bottom sides. 2y plus 2 must be the same as 3y minus 9, right? Opposite sides should be congruent. Subtract 2y. 2 equals y minus 9. Add 9. 11 is y. There's 11. There's y. And now to find x, well, 3x plus 6 should be equal to y plus 4. Y is 11. So 3x plus 6 should be equal to 11 plus 4 is 15. Subtract 6. 3x is 9 and divide by 3. And x is 3. And there are the two values of the variables that make the opposite sides congruent, which would then make this a parallelogram. 7 here. L, M, N, P is a rectangle. Find the value of x and the length of each diagonal. So let me draw this picture. L, M, N, P. Just double check that LN is a diagonal and MP is a diagonal. Yes, these are diagonals. In a rectangle, diags of rectangle are congruent. So all we're going to do is set them equal to each other. 3x plus 5 equals 9x minus 10. Subtract 3x. 5 equals 6x minus 10. Add 10. 15 equals 6x, and divide by 6. And x actually comes out to be 5/2 or 2.5. Okay. So now to find the length of each diagonal, just plug it back in. ln equals 3 times 2.5 plus 5. So ln, that's 7.5 plus 5, that's 12.5. And that's also going to be MP. If you want to check, you can, but it should be 12.5 as well. Okay, just make sure you remember those properties, right? Diagonals of a rectangle are congruent. Alright, here you go. This is a fun question. Find the angle measures and the side lengths of the rhombus at the right. Okay, so it wants the angle measures and the side lengths. So look what we have here. Okay, we have this picture. Let's start with the angle measures. Now remember that this is a parallelogram, right? A rhombus is a parallelogram. Notice your angle measures, x and 2x plus 6. They're consecutive angles. We still can use the fact that consecutive angles of a parallelogram are supplementary. So we can still use the fact that x plus 2x plus 6 will equal 180. Combine your like terms. Subtract 6. Divide by 3. Divide by 3. And you get x is 58. So there's angle H and J is 58. So then to find the other one, 2x plus 6. So 2 times 58 plus 6, that's 116 plus 6, that's 122. So angle G is equal to angle K is equal to 122 degrees. So there's your angle measures, all because the consecutive angles are supplementary. And now we have a rhombus still, and in a rhombus, all 4 sides congruent. All 4 sides congruent. So I can pick any 2. There are 2 variables, b's and r's. I don't care which 2 you pick. Let's do, I'll do the r's. So r plus 1 is going to equal 2r minus 4. And it doesn't matter. I can do the same thing with the b's. Subtract r. 1 equals, let's subtract r. R minus 4, add 4. R is 5. And if r is 5, we plug it back in. 5 plus 1 is 6. So all sides equal 6. And there you go. So there's the angle measures and the side lengths in this rhombus. It's a good question. Here we go, number 9. Can you conclude that the parallelogram is a rhombus, a rectangle, or a square? So first of all, understand this is a parallelogram. So now, look at the marking. This means that the diagonals are perpendicular. Well, what one is that for? That's for a rhombus. So check. This is a rhombus. Now, we also have to see if it's going to be a square. And if it's going to be a square, it has to be a rectangle. So is it a rectangle is the question. Well, there's 2 things that would tell you that. 1, all 4 right angles. Well, there's nothing given about the corner angles, so no. The second thing is diagonals would be congruent. But there's no markings on the diagonal. So this is not a rectangle. And if it's not a rectangle, it can't be a square. So that means it is just simply a rhombus. Okay? And this is, again, good work to show. Make sure you go through all the possibilities. And then lastly, for what value of x is the figure a rectangle? Now this is tricky, because if it's a rectangle, then these corner angles are right angles. But notice that these 2 are just the little sliver angles. They're not the entire thing. What do we know about a rectangle? Well, we know that the diagonals of a rectangle are congruent. And because it's a parallelogram, we know that the diagonals of parallelogram bisect each other. So remember that idea that because they are congruent and bisected, all 4 are the same. And now I suggest you focus your attention on this triangle. and ask yourself what kind of triangle it is. Two sides congruent. It's isosceles. You have an isosceles triangle. You need to use the isosceles triangle theorem, which says that if two sides are congruent, the angles opposite are congruent, and those two angles opposite are the two angles we are given. So 3x plus 4 equals 4x minus 12. That is the reasoning why you set them equal. Maybe you assumed to set them equal, but you should not assume. This is the reason why. And we subtract 3x. 4 equals x minus 12. We add 12 to both sides. And x is 16. And there's the value that makes this a rectangle. Went through a lot of problems in a short amount of time. Hope this helped. Hope you're able to practice, and we'll see you on Thursday.